Hi everybody, we're the MOSafely Social Media Risk Detection Dashboard. My name is Alex Kohler. I worked on the front end and the back end.
My name is Zach Earhart and I worked on front end.
My name is Stefania Sanchez and I worked on machine learning.
I'm Ryan Doherty and I worked on the machine learning in the back end.
I'm Kenneth Tran and I worked on the database. For our project, our sponsors are Ashwak Alsabai and Dr. Pamela Wisniewski from the STIR Labs. I'll be doing a project overview. 95% of teenagers have smartphones. That's been shown by Pew Research in 2018. There's currently a lack of machine learning research being done with conversations between sexual predators and their victims. Private companies do not currently open source any of their tools to public use, such as Bark. Most of the tools currently available are not victim-centered. For our project motivations, many of us have had family members or friends that had to deal with cyberbullying or any sort of sexual harassment online. 89% of sexual solicitation from minors are mostly made online through messaging. This has been shown in Pew Research. 59% of minors have experienced cyberbullying.
Now onto the project overview. Our site is aimed towards helping teenagers between the ages of 14 and 21 to help them detect risky behavior online. Users will submit their Instagram and Twitter data to our website, and our machine learning algorithms will go through their direct messages and then provide feedback on what the risks are. The two risks that we're mainly aiming towards are sexual risks and cyberbullying risks. And our job during the 2 semesters was to redevelop and redesign upon the first iteration of our website. Some challenges and lessons learned that we had. The challenges that we had, the Lambda functions that we inherited were not properly configured and the code did not work, so we had to go through and revamp all of that. We also had issues getting a hold of the research data in order to train our machine learning algorithms. Once we got a hold of it from our IRB, the Internal Review Board, there are an ethics committee that approved the 2 people working on the machine learning and research data. And now the lessons learned. We had some issues with adaptability on getting used to the whole project, some team management as far as making sure everyone is doing their part and contributing to the team, and of course improving our individual skills and cohesion throughout the whole project.
So a quick overview of the machine learning work that we did. The first iteration of this project included conversation level risk classifiers written by the graduate students at STIR Labs. To expand upon this, we created message level risk classification algorithms for both cyberbullying and sexual risk. These algorithms allow users to see which specific messages within their Instagram or Twitter data contain either type of risk. The first step of this process was analyzing and pre-processing the data. We wanted to give the models the best possible quality of training data in order to get the optimal performance. STIR Labs has collected over 5 million real messages from teen participants, and we use these messages to curate specific cyberbullying and sexually risky datasets. From there, we did standard pre-processing used in natural language processing, such as stemming, lemmatizing, and stop word removal. We experimented with different kinds of vectorization as well. Simple methods such as count vectorizer or TF-IDE did not prove effective for our purposes, so we transitioned to neural network-based methods of vectorizing. Word2Vec generates vectors for words based on their similarity to each other, so synonyms will have more similar vectors. BERT and BERT-based models like Electra use sentence-level context of the word to generate vectors. For example, if we have the sentences, I robbed a bank and I sat by the riverbank, the word bank means 2 different things in each, so it would have 2 different vector representations.
Hi, I'm Ryan. I worked on the transfer learning for the Electra model. We used a pre-trained state-of-the-art Electra model based on the general English language, and we experimented with different types of models on top of it, including bidirectional LSTMs and deep neural networks. And after a lot of complex training methods beyond the scope of this video, it gave us very high accuracies compared to the other methods mentioned before. Here's a graph of our tensor board of the binary accuracy over time, with the top 2 lines being the training accuracies for each of the risks, and the bottom 2 being the validation, with the lowest one being the cyberbullying and the one in the middle being our sexual classifier as it performed better. Here's the graph of the loss over time, with the lowest lines being the training loss and the higher ones being the validation, with the same colors as before. For the model evaluation, we used scikit-learn's classification report and confusion matrix to evaluate the performance of our models. Here's an example of a nice graph we made of our confusion matrix showing our false positives, false negatives, and so on.
On this slide, we can see an overview of the performance of all of our models on the site. The two models that we developed in this iteration of the project are highlighted on the table. In comparing message level and conversation level models for cyberbullying and sexual risk, we can see that our models greatly outperform or almost match the performance of the conversation level models. For cyberbullying, we have a 68% conversation level accuracy versus an 82% message level accuracy. And for sexual risk, we have an 89% conversation level accuracy versus an 87% message level accuracy.
All right, so next we're going to be talking about the data pipeline. So first up is going to be the AWS integration, which stands for Amazon Web Services. The data from the user is then uploaded to platform-specific Amazon Web Service S3 buckets. So that's going to be holding the zip file where the user stores their data, divided amongst the Twitter and Instagram S3 buckets respectively. The user's data zip file is then processed by our AWS Lambda function, which passes clean data arrays to the ML API for prediction processing. So what that means basically is that when the user uploads their data, the data is then looked at and kind of cleaned and sorted into messages, timelines, usernames, etc., so that the machine learning API can go ahead and do its work and divide the messages into categories of sexual, cyberbullying, etc. Those predictions and the data are then stored in the site database, as well as images. If those contained in the messages, those are also stored in a separate Amazon S3 bucket so that our website can pull them and display them amongst the messages. Next up, we did a variety of testing when it comes to actually testing the functionality of the website. So first we had our standard performance model for the machine learning evaluation. We tested the machine learning API done with Postman so we could get our predictions before we actually implemented them on the site. After that, we uploaded our zip files. So we had a variety of test zip files to our website to test the Lambda function to make sure that it was completely functional, both the Twitter and the Instagram data. Then we attended MOSFest. So MOSFest is kind of short for Mozilla Festival, in which we were able to demo our project to a variety of people, including professionals and teenagers, to kind of get their feedback on the site. In terms of the front end, we also displayed different screen sizes so we could test how the consistency amongst various monitors. We also tested multiple browsers to ensure different functionality. And then for the results page, we stress tested it by using various conversations, messages, as well as a different number of messages, and then different sort of column heights to make sure that every user's data will be uploaded consistently. We also attended STEM Day, in which we allowed teenagers and kids to test our Bully Me machine learning API, which is basically just a shorthand version of the teenagers can type in basically anything they want and get a result as to whether or not our actual server site would classify that as sexual or cyberbullying risk.
This is the MOSafely Social Media Risk Detector homepage. Clicking on the center button will let us get started. From here, we can choose to log in to an already existing account, or we can create a new account if we choose to do so. Today we're going to be going ahead and logging into an already existing account to demonstrate the upload feature. Proceeding through this page, which gives you a little bit more information about donating your data, will lead you to the Terms of Service and Privacy Policy, which explains a little bit about how we use the data that teenagers give us online. Clicking Next allows us to come to the Upload Tree page, in which we can select between Twitter and Instagram which site we would like to upload our Twitter data from, or Instagram data for that matter. There's a very brief overview of how you can download your Twitter data if you don't already know how to do so. Luckily, we already have a zip file prepared for this purpose, so we're going to go ahead and select that file and then hit Submit.
Once the user's data has been uploaded, it will take them to the Risk Assessment Dashboard, where they can see an overview of all of the risks associated with their conversations. They can click on one of these cards to sort it by the associated risk, so we'll go ahead and click on cyberbullying. And indicated by the icons, we can see here at the bottom that it did sort it by the bullying risks. Then we can go ahead and click on a conversation. And the goal of our project is to have users submit feedback on our machine learning algorithm's output. And so we ask users to go through each message and confirm whether or not the risk is correct. This one has a confident sexual risk and a confident bullying risk, and so we'll go ahead and say that this one is correct. It will flag messages from the uploader and the sender of the messages. So if a user thinks that their messages are not risky, then they can go ahead and provide feedback. and save their changes, and it will update accordingly. We have a legend for users to see which icons mean what, and what confidence level is associated with each color. Our system also flags conversation level risks, so if a user thinks that a particular conversation doesn't have any risks associated with it, they can also provide feedback on that as well, and change the relationship they have with the user so that we can better understand why the risk is not associated with this particular user.
So to conclude this presentation, the MOSafely Dashboard's ultimate goal is to provide a safer world for youth through technological innovation.